Hello everyone, I am Haiying Che from Institute of Data Science and Knowledge Engineering, School of Computer Science in Beijing Institute of Technology. In this session, we will discuss data reduction. Complex data analysis of large-scale database content usually takes a lot of time. Data reduction technology is used to help obtain a condensed dataset from the original huge dataset and make this condensed dataset maintain the integrity of the original dataset, so that data analysis on the condensed dataset is obviously more efficient, and the results of analysis are basically the same as those obtained by using the original dataset. Data reduction work should satisfy some standard. First, the time spent on data reduction should not exceed or offset the time saved by analysis on the reduced data. Second standard, the data obtained by the reduction is much smaller than the original data, but can produce the same or almost the same analysis result. Data reduction technology includes dimensionality reduction and numerosity reduction. And dimensionality reduction includes attribute subset selection, principal component analysis, also called PCA, and wavelet transform. Numerosity reduction could be divided into parametric and non-parametric method. Non-parametric methods include data cube aggregation, clustering, sampling histogram, etc. First, let's look at dimension reduction. Remove irrelevant attributes and reduce the amount of data processed by data analysis. Attributes subset selection goal is to find the smallest attribute subset and ensure that the probability distribution of the new data subset is as close as possible to the probability distribution of the original dataset. For example, when digging into the classification rules of whether a customer will buy a player in a shopping mall, the customer's phone number is likely to be irrelevant to the analysis task and should be removed. And we have several attribute subset selection methods. Step forward attributes subset selection, starting from an empty attribute set, which is the initial value of the attribute subset. Each time, a current optimal attribute is selected from the original attribute set and added to the current attribute subset, until the optimal attribute cannot be selected or a certain threshold constant is met. Remove gradually backward attributes subset selection. This method starts from a full attribute set as the initial value of the attribute subset, and each time a current worst attribute is selected from the current attribute subset and eliminated from the current attribute subset, until the worst attribute cannot be selected or a certain threshold constraint is met. Sometimes we can combine the forward selection and backward selection method together to select the subset attributes. Decision tree induction. Use the decision tree induction method to classify and induct the initial data to obtain an initial decision tree. All attributes that do not appear on the decision tree are considered irrelevant attributes. Therefore, delete these attributes from the initial attribute set to obtain an initial decision tree, a better subset of attributes. There is also other reduction based on statistical analysis. Now let's look at data reduction by data compression. Compression algorithm can be classified into lossless compression and lossy compression. Lossless compression means compressed data can be restored without losing any information. For example, string compression, which has a broad theoretical foundation and a sophisticated algorithm. Lossy compression means only an approximate representation of the original data can be reconstructed. For example, audio-video compression is this case. Sometimes it is possible to reconstruct a fragment without decompressing the overall data. Data compression uses data encoding or transformation to obtain a compressed representation of the original data. The two commonly used data compression methods in the field of data mining are both lossy. Principal component analysis, PCA, assumes that the data to be compressed consists of n tuple, or data vectors, taken from k dimensions principal component analysis search to obtain c k-dimensional orthogonal vectors that best represent the data, where c less or equal to k. In this way, the original data can be projected into a smaller space to achieve data compression. We talked some technologies of dimensionality reduction, and now let's look at some technologies of numerosity reduction. Numerosity reduction uses smaller dataset to represent original dataset, or use shorter data unit, or use data models to represent data to reduce the amount of data. Numerosity reduction includes data cube aggregation, clustering sampling, histogram, etc. Let's look at the data cube aggregation first. A data cube is a multiple-dimensional modeling and representation of data composed of dimensions and facts. Here, dimension means attributes, and facts means data. Data cube aggregation definition is to gather n-dimensional data cubes into n-1 dimensional data cube. We can use data cube aggregates for approximate query. In the diagram, 3-dimension data cube aggregate into 2 dimensions. The man and woman's sales amount is aggregated together. Now let's look at the data reduction method, discretization. Attribute values could be name, type, example value in an unordered set, ordinal, example value in an ordered set, and continuous value, example real numbers. Discretization technology reduces the number of values of a continuous value attribute by dividing the range of the attribute domain value into several intervals. By doing this, we can reduce the amount of data. We can also use concept hierarchical generation to do the data reduction. Concept hierarchy defines a set of mapping from low-level concept set to high-level concepts set. It allows data to be processed at various levels of abstraction, thereby discovering knowledge at multiple levels of abstraction. Use higher-level concepts to replace lower-level concepts to reduce the number of values, such as the value of age in this example. Although some details disappeared in the process of data generalization, but the generalized data obtained in this way may be easier to understand and more meaningful. Data analysis on the reduced data set is obviously more efficient. The concept hierarchy can be represented by a tree, and each node of the tree represents a concept of certain level. In this session, we learned data reduction and related technologies. Thank you for your attention. If you have any question, feel free to contact me.